way to go. It's being done a lot.
For number 1, you needed to find the range of this list of numbers. So you're looking for your y values. You need to list them least to greatest without any repeats. So this would be -5, -3, -2. Questions on that one?
I only got the -1 answer. I didn't get the fraction. I didn't know.
Right. For the second one, this asks how many solutions does this have? So as you start to solve this, you would distribute to get 6x plus 6 minus 3x. Combine your left terms to get 3x plus 6 equals 6 plus 3x. At that point, if you recognize that these are the same, they're the switch, you could say that this is going to be infinitely many. If you didn't recognize that, you would keep solving. So let's say I subtracted 3x on both sides. I got 6 equals 6. Then that would be a true statement. This would be infinitely many solutions. What questions do we have on that one? Number 3, you need to solve this for y, so get everything away from y. Add x to the other side, and then rearrange this so that it's 3y equals x minus 3. Divide everything by 3. So you have y equals 1/3 x minus 1. What questions do we have on that one? Yes. Preston. Preston. Don't lean in your chair, please.
Wait, Preston's attention as well?
I have no idea what you just said.
What?
I said no. I said don't lean in your chair.
Oh.
And take one of your earbuds out.
Wait, you didn't say his name?
Yes, I did. That's not what I said.
You're just hard.
Tell me some more.
No.
Tell me something.
He doesn't have detention. Here.
Run in there and just tell me something new. Interesting.
Number 4, you needed to cross multiply. So take your 5, multiply it to the denominator, and vice versa. It does not matter the order in which these are written. Distribute. And then you need to move something to the other side. It doesn't matter what you did. If yours is not the same as mine, that's okay. As long as at the end you get -3x equals 6. Divide both sides by -3 to get -2. What questions do we have on that one? And number 5, we're looking for the domain of this graph. So we're looking for furthest left to furthest right for just the x values. This would start at -3 and then end at +1. You can write this one of 2 ways. Let's look at inequalities and set double notation from -3 to 1. Or using your interval notation, you have endpoints here. So this would be in square brackets from -3 to +1. Okay. Because there are points here. If there were open circles at these endpoints, then there would be parentheses. Other questions on these? Before we get into our notes for today, everyone look at your course calendar. It is yellow, not gold, but same thing. I want you to be aware of the dates coming up. the Khan Academy dates, the quiz date, the test date. So make sure you're aware of those. They are posted in Canvas. They're also on the board. What is not on that is your benchmark date. So right after we test this, we'll have like a week where we're going to start the next unit. But then the week after that, we're going to be doing benchmark stuff. This unit will be the last unit that goes in this marking period. So if you need to take the benchmark, you'll need to have all of that stuff done, all of the test corrections, Khan Academy, Delta Math, and additional practice done before you can do the benchmark on those dates. So for you guys, it's going to be the 31st, which is a Thursday. I would not wait until then. Yes, you'll have some time towards the end to work on that stuff too, but don't wait until then. Come see me after school, before school, to get that done as soon as possible. Just so that you remember, everything that's going to be on the benchmark is Unit 5, so your variation stuff. Some of you still need to take that test or finish it. Come see me as soon as possible to get that done. The factoring test we just took, some of you need to finish that. Come see me after school or before school to work on that. And then this unit that we're going to start on quadratics. Does anyone have any questions on anything I just said? Yes.
I just want to say something before we start this.
Yeah, go ahead.
Coming up. It's related to this year, guys. It's very important. How many of you guys know your ABCs? You guys remember your ABCs? Preston?
Yeah, I know what.
All right. Well, this unit, you got to know if you get your A, you know your A and your B and your C in this coming unit, you'll be in good shape.
And if you don't,
You don't, you're not going to be in as good
well,
shape.
Mr. Story, you might as well just give me that.
Pay attention here. Know what A and B and C are, and you'll be a long way to doing well in this unit. All right, Ms. Thorpe, take over.
Alright. So everyone should have notes that look like these. Get those out in front of you. Many of you start off these units not paying attention. Don't let that be this unit. Make sure you're paying attention. Okay. So we are going to be focusing on quadratics. We've really been talking about quadratics since the last unit. We just never said that specifically. We were factoring quadratics before. Really anything that has something that's squared is a quadratic. When we solve them, we're looking for like the solutions, the x-intercepts. And there are different ways to solve them. We are not going to talk about all of the different ways. You'll do more of that in Algebra 2. There'll be a whole unit on quadratics, and you'll go in more depth. We'll just talk about the basics. One of the ways to solve is using square roots. But when we use this, this only applies if there's not a middle term. So usually when we have trinomials, we have the ax squared plus bx plus c. That's what Mr. Northrop was talking about, the ABCs. In this method, we cannot have a bx, or that middle term. If we do, we can't use this method. So with this, we're going to isolate the x squared. So if I'm trying to get x squared by itself, what would I do? Okay.
Plus 49 to both sides.
Add 49 to both sides. We have x squared equals 49. Our next step is going to be take the square root of both sides. So part of this is like when we were doing difference of squares. What times what would give us x squared?
X.
X. If you're not sure what this would be, first, if you don't have your calculator, go grab it.
Everybody go get your calculator. Hit him, go get your calculator. Now.
I don't, but I can tell you.
That's mine.
That's what I remember.
That's my favorite thing.
19.
I'm 24, right?
I'm waiting just
Yes.
I swear to God.
No.
I didn't say I could smell so much my camera.
Make sure you actually get your calculator, not using your calculator on your phone.
You're looking small and walk away. Hello. Why?
This is not my calculator.
You don't know?
It's not.
You don't have specific.
Really?
Yes.
They can. Honestly, why not?
He has specific.
You only live life once. Bro, Kato, this is the 2016 vibe. Miss Thornton, you don't look at Kato how he's dressed. You feel like he's finished at 2016.
What's wrong with that?
That's all you ask.
What's wrong with that?
There's nothing wrong with that. I just find it funny.
Why is that funny?
And this is why I talk about his ethnicity.
She did not like that one.
No, bro, that's fine.
Miss Thornton, no way you let him stay after that comment.
This is the energy we want, Matt.
Wait, what do you say?
Nothing important.
There's just no way you let him stay after that, Miss Thornton.
Caleb. Stop talking. Okay. If you don't know what the square root of 49 is, you can put it in your calculator.
7.
Yes. And we're going to calculate this. So, second x squared will give you your square root. And then you can put in whatever number you need. So if I put in 49, it would give me 7. Yes, we know that the square root of 49 is 7. However, when we write our answer, we're going to do it a little differently. Because we know that 7 times 7 gives us 49. The same can be said about negative 7. Because negative 7 times negative 7 is also positive 49. So when we write our answer, we're going to include both the positive and the negative version of this number. Usually you see them together as plus minus.
Wait, that's all this is? That's it?
There's one last step. Write them as a solution set, so x equals, in curly brackets, your lowest number, so your negative 7, and your highest number, which is positive 7.
Bless you. You're very welcome.
Before we continue, what questions do we have on that? We are going to do some more together, starting with number 1. So same process, Josh.
Do plus 16 on both sides. Then you bring down the x2 equals 16. Then you find the square root of both. Square root of 16 is
4. So we would do plus or minus.
not positive, right? That's
We have to do both, plus and minus. And then our solution set would be x equals, in curly brackets, negative 4, 4.
Wait, what? No, it's not hard.
Walk me through, someone walk me through, how would I do number 2?
Add one on both sides. Bring down the x squared and equals to and then for the square root. So x equals
Yeah.
Bro, why take it up?
Again, you go, we're missing something?
Plus or negative.
Plus or minus 10. And then our solution set, x equals negative 10, positive 10. So both of these are really the answer, but this is the answer form that it needs to be in.
So you preferred having both those answers?
if you went from the square root of x squared equals the square root of 100 to x equals, in curly brackets, 10, negative 10, that would be fine.
Wait, this door.
However, some of these you'll need to solve more, so you will need to get to this point first. What was your question?
Okay, so let's say, so where you put x equals as 10, right? Right, let's say x equals 10. Let's say if it were to be a negative 10, would it be x, curly bracket, 10, negative 10?
Lowest always goes first.
You just call it a curly.
It is a curly bracket.
Oh.
Look at you. Alright,
Did that answer your question?
yeah. Thank you.
Alright. For number 3, now this is a plus, so we would subtract. In your calculator, do the square root of negative 25. Humor me. Put in your calculator.
5.
Humor me. Put in your calculator.
It's gonna show an error. It's gonna show an error.
So, in Algebra 2, when you move on to that, you'll talk all about this non-real answer and how you deal with that. We are not doing that in here. So when you get a negative underneath the square root, or you know that this side is negative, so it would give you a non-real answer, you're going to say that this does not have a solution. That equals no solutions, the 0 with the line through it, either of those. Questions on that?
It says x equals what? ms?
It has no
And as no solution.
No solution, right?
If you have a negative number and your x squared is isolated. If it's not isolated, that could change. So we'll deal with some examples like that in a second.
Wait, I don't. Because isn't that perfect square? Wouldn't it be 5?
If the negative wasn't there, then yes. But because the negative is there, we can't do this problem.
So if they're negative, they have no solution in this technically.
Yes.
Got it.
Technically, there would be an I, because that's the square root of negative 1, which we're not talking about in this class.
Got it.
For number 4, now when we solve this, it's not equal to 0, but we're still doing the same process, getting 7 away from it. So we get 81. 81 is a perfect square, and it would be plus or minus 9. So negative 9 and positive 9 would be our solution set.
It's pretty simple.
Good.
For right now.
It only gets a little bit harder for this.
Oh, okay.
I'm hoping.
Is this like the easiest one that I can do all year?
No. I feel like inequalities was pretty easy because we knew it for the most part. For number 5, when we start solving that and we subtract 7, what happens?
negative 3.
So what type of solution would that be?
No solution.
So as soon as you see that negative, you can stop and say this is going to be the solution. You could keep going, yes, and do the square root of negative 3, but you would get a non-real answer.
Wait, for number 6, I know we're not doing that one, so it's, but if this is x squared equals 1.
What's the square root of 1?
1.
So it'd be plus or minus 1. Great. For number 7, we're going to skip 6. If I need to isolate the x squared, how would I do that? Divide it. by 6 on both sides. We have x squared equals 9. 9 is a perfect square. We can take the square root of both sides. So x equals plus or minus 3. X equals negative 3 and positive 3.
Where are you getting things from?
If we take the square root of 9,
Don't say you just square it to the max.
so take the square root of it and then add plus or minus. Skipping to 9. Now we have this fraction in front of x squared. Remember that usually we divide it, but if we divide it by 3/4, we end up with a fraction within a fraction. We want to avoid that. So we're going to multiply by this fraction, flip to 4/3 on both sides. These would cancel on this side. If you don't remember how to use your fraction button, in your calculator you would have 12 times alpha y equals will give you your fraction bar, that first one. And then I could put in 4/3 to get my answer of 16.
Wait, I'm trying
On which part?
to, when you multiply 4/3, you gotta put it to the other side.
To multiply it on both sides. We didn't add it, we multiplied it.
Oh. Wait. And then you got, what did you get after?
16.
Oh.
So this would be x squared equals 16. Take the square root of both sides. Get x equals plus or minus 4. And negative 4 and 4. So far, what questions do we have on this? On number 10, we need to isolate the x squared, but there's a bunch of stuff going on. What would we do first? Multiply by 2 is what you were thinking? So if we did that, now in this case, it wouldn't really do much. But if that fraction had a 3 in it, and then we start multiplying by the reciprocal, let's say it was 3/4, and we multiply by the reciprocal, 4/3. Now we have fractions over 3 that we don't want to deal with. So instead of doing that first, get rid of the number by itself. So add 5 to both sides.
So I can just find the reciprocal again.
And now we can multiply by the reciprocal, yeah. So we would multiply by 2/1. So x squared would equal 100. When we take the square root, that would give us 10 plus or minus 10. Negative 10 and 10. Before we do some problems on the back, how do we feel about this so far? Thumbs up for good, sideways for okay, down for not good. We're going to try some on the back. Anyone still need this one? We're going to start with number 16. With number 16, the process is the same. We're still getting x squared by itself. So we would do what first?
Plus 16.
Add 16 to both sides. We have 9x squared equals 16. Then we're going to divide both sides by 9. This is going to give us some fraction. That's okay that it gives us a fraction. I'm still going to take the square root of both. But when we take the square root of a fraction, if both are perfect squares, then we can really separate this so that it's the square root of the top and the square root of the bottom. So the square root of 16 over the square root of 9. We know what those pieces are. The square root of 16 is 4. The square root of 9 is 3. So when we do this, this would be x equals plus or minus 4 over 3. So our solution set would be x equals negative 4 over 3 and positive 4 over 3. What questions do we have on that one before we do some more?
We have a fraction. We have a fraction that we can't simplify to both squares, like to the square. You know what I mean?
I'm going to say probably.
And then we'll end the fraction.
We'll deal with that. We'll actually get to some problems like that in a second, and you'll see what happens. Any other questions on that? Let's do 17. Same process. Add 1 to both sides. Divide both sides by 4. This can't be simplified like this. But when we take the square root of both sides, we could separate it because 25 and 4 are both perfect squares. And it would be 5 and 2, plus or minus 5 and 2. So our answers would be x equals negative 5 over 2 and positive 5 over 2. Number 18. When I subtract 16, I get negative 8. What would I do from there? Heard someone say something, but I didn't actually hear that said.
It's a negative, but no solution.
Right. So even though we have other things that we could do, this doesn't have like a negative here, so it's not going to magically change this to a positive. So no matter what, this is still going to end up with some negative underneath the square root, so this is going to be a no solution. Where you find that doesn't really matter. If you, that first step, after you see that, it's a negative, and you realize it's going to be no solution, go with that. If you wait until you've isolated this completely and then you go to take the square root, you put it in your calculator and you get the non-zero answer, then you still know it's no solution. Have any questions so far?
Yeah.
Let's do number 19. For 19, this is already isolated. So we're going to take the square root of both sides. Do we know what the square root of 19 is off the top of our heads? No. 19 isn't a perfect square. So when we do this, we're going to get a decimal. I'm going to put in square root of 19. Whatever that decimal is, that's the answer we're going to use. Up to like 3 decimal places, you can round. So 4.359 would be our answers. So our solution set would be x equals negative 4.359 and positive 4.359. There is a way to simplify square roots that are not perfect squares. This one actually couldn't be separated, simplified, I mean, but we're not doing that. So once you get it isolated, take the square root of it. It could be fraction, decimal, whole number. It just depends on what's given. But also be careful with that. Because you could get a decimal or a fraction, you may have solved it incorrectly and may not know unless you get it checked. What questions do we have on that? We're going to do 5 more together, and then I'm going to give you some to practice. Number 21.
Add 40 minus 5.
Subtract 5 on both sides. We get 12. And then take the square root of both sides. I put 1. There we go. So 3.464 would be our answer. Positive and negative. $22. How would we solve that?
Plus 126.
Add 126 to both sides. We have 2x squared equals 126. And then divide everything by 2. X squared equals
63.
take the square root of both sides. I'm just going to put x equals the negative and positive in the solution set. So 7.937 to use at least 3 decimals. $24. How would we solve that?
Plus 6. 24, then you divide by negative 8.
Negative 24.
Yeah.
So here, we do an example like I was talking about before. It has a negative, but x is not completely isolated, and if we divide by a negative, that may change. Here, when I divide both sides by negative 8, we get a positive 3. So that changes. We're going to have a solution here.
Wait, what's the square root of 3?
Put in your calculator, you tell me.
I think I did it wrong.
What do you get?
No, I don't know. I rounded it. Whatever.
second x squared to get the square root.
Thank you. 1.7.
1.732. $26. How do you sell that? Close one. Add 1 to both sides. 4/5 x squared equals 8.
Multiply 5/4.
Multiply both sides by 5/4. So 8 times 5/4. So there's no 8. 10. And the square root of 10 is 3.116. I just didn't hear you. 3.16. Okay. The last one we're going to do together. Number 27. There are 2 different ways to go about doing this. You could either distribute first, or you could get rid of that fraction first since it's on the outside by multiplying by the reciprocal. This one will be okay to multiply by the reciprocal because 6 can be divided by 3. If it was a number that could not be divided by 3, then that would not be the best idea. So if we multiply both sides by 4/3, we get 8. Now our parentheses are going to disappear. X squared minus 17 equals 8. Add 17 to both sides. 17. What is that? 20, 25. Now we're back to perfect squares. Okay. So I'm going to give you some practice problems that I want you to do, and then we'll come back towards the end and go through these. So circle these or whatever so that you know these ones are the ones you're doing. Numbers 6, 8, 11, and 12 on the front. 6, 8, 11, and 12. And then on the back, 13, 20, 23, 25, 28, and 30. That was a lot. 13, 20, 23, 25, 28, and 30.
All right, Preston, you ready?
No.
You don't want to play?
For what?
Huh?
For what?
Jolly Rancher? Want to play? All right, here's the game. What letter of the ABC have...
So starting with number 6. These are not in the correct order, but this is not my handwriting. -1, 1 were your solutions. Number 8, negative 7, 7 were your solutions. Number 11, negative 12, 12. Number 12, negative 2, 2. Do we have any questions on those? On the second page, number 13 was negative 6, 6. Number 20, so these only have 2 decimal places, and I don't remember what the third is, but negative 6.40, I think it was 3, and then positive that. 23 should have been a fraction. Keep that one as a fraction because it has perfect squares. So negative 5/3 and positive 5/3. 25 was negative 7.94 and whatever the third decimal was, and positive of that. 28 was negative 8 and 8. And then 30 was negative 6/5 and positive 6/5. If anything we did today did not make sense, come see me after school or before school to work through these problems. And also, you have 1 Delta Math on this due next class, and 3 Khan Academies on just this due on Friday. Each one is something a little different, like one walks you through the steps, one is like, this person solved this, which step did they make a mistake, and then one is you actually solving it. So make sure you get those 3 done by Friday. And if you're still missing a test, come see me before or after school as soon as possible to get that done.